Hello everyone, Namaste. This is Dr. Prerna. I am teaching as an assistant professor at Hansraj College, Department of Chemistry, University of Delhi. In these videos, we are discussing the elective paper, Interfacial Electrochemistry. This is an elective paper offered in all the colleges across DU. So every student who are reading this paper can watch these videos and prepare their paper for their incoming exams. So let's quickly start with the topic. The paper is elective course known as Interfacial Electrochemistry. So the first thing is we are going to read that what is electrochemistry, what is interfacial electrochemistry, and what are the importance of electrochemistry in our surrounding. So just quickly jump to the topic. First we will do introduction to the interfacial electrochemistry. So as the name suggests, it comprises of two things: interface and electrochemistry. When we talk about interface, we talk about that there are two things: electrode and electrolyte. So there will be a kind of interface which is electrode electrolyte interface. And since electrode is comprised of a metal and electrolyte is a liquid, so this slash represents the phase change. And now what is electrochemistry? Electrochemistry suggests that electrochemistry means electron and chemistry, which means that chemistry of electricity. Electricity means flow of electrons, so the science which deals with the flow of electron is known as electrochemistry. Electrochemistry is actually a very vast and broad range of science, because it has fundamental as well as applied important importance in fundamental as well as in the applied systems. Whatever we see around us, like sensors, batteries, these are electrochemical devices. So electrochemistry is very important for considering it, if we consider its application part as well. So when we are talking about electrochemistry, first thing which will come into our mind is that electrochemical, what is an electrochemical reaction or what is an electrochemical cell. So first thing we will learn is what an electrochemical cell. So in any electrochemical reaction, whatever happening is, we are considering that in an electrochemical reaction, at what factors are responsible for that reaction to take place, and what are the processes which are occurring at the interfaces. So it's very important to consider the factors and the process which are occurring in an electrochemical cell. So since we are talking about the interfaces, so an electrochemical cell is actually comprises of several interfaces. We cannot segregate any kind of electrode electrolyte interface. So we study the phenomena at interface using an electrochemical cell. So electrochemical cell consists of three electrodes. From our earlier classes, we know how to represent an electrochemical cell. It consists of a metal electrode and an electrolyte. So there are two things: electrode and electrolyte. Now, what is electrode? Electrode, we can say that it is an electronic conductor, and electrolyte is our ionic conductor. Means the flow of electron or the flow of current will take place through our electrode, that is electronic conductor, and the flow of current which is occurring due to the ions in the solution, that is our ionic conductor, electrolyte. So basically electrolyte provides more conductivity to our electrochemical system. So both these electrode and electrolyte, they have their own importance in an electrochemical cell. And now if we consider a very simple example, let's say Daniel cell. So how to represent an electrochemical cell? Let's consider that we have a zinc electrode and we have dipped it into zinc sulfate solution. So in this way we represent an half cell of any electrochemical cell. Slash represents the phase change because zinc is our metal electrode and zinc plus 2 is our solution. We represent it as aqueous solution. So this is the representation of any half cell for an electrochemical cell. Electrochemical cell is actually comprised of two oxidation half and reduction half. So we can represent in this. So this is kind of a half cell. Okay, so now talking about what are the main elements of an electrochemical cell. Generally, to carry out any electrochemical measurement, we consider three electrode assembly. In order to compensate whatever the ohmic losses or whatever the potential drop is occurring in our system, so three electrode assembly is the best way to carry out any electrochemical measurement. So what are the components for three electrode assembly? So the components of an electrochemical cell consist of: first, working electrode; second is your counter electrode; and third one is your reference electrode. Okay, so working electrode, counter electrode, and reference electrode, all these electrodes have their own importance in an electrochemical cell. First, let's talk about very quickly about all these three. Working electrode. Working electrode is your main electrode at which you are applying your potential, and whatever reaction you are studying it with respect to your working electrode. It is your main working electrode. So now what kind of electrodes you can choose? So like for example, if you want to study the electrochemistry for any metal electrode, so you can choose any metal like platinum, gold, silver, whatever. And if you want to study any carbon chemistry, let's say, so you can choose graphite electrodes, graphenes. You can choose those electrodes. And if you want to study any semiconductor electrochemistry, then you can choose semiconductor materials. So these are their working electrodes, right? Now, what is counter electrode? Counter electrode is also known as auxiliary electrodes. Counter electrode could be any metal, whatever is feasible for you to carry out your experiment. It's only important that the main reaction should occur on your working electrode, and no other reaction which can interfere your main phenomena, your main reaction, that shouldn't happen on your counter electrode. So counter is basically just act as a sink for your reaction, so that excess flow of current can go through counter electrode. So like let's say if you are using platinum as your working electrode, platinum metal electrode, then you can use platinum sheet as your counter electrode. Then what is the difference between working and counter electrode? Basically, let's say if you are choosing your platinum metal electrode, it's a very thin wire electrode. Let's say area of your working electrode is around 0.12 centimeter square, let's say. Then how to choose your counter electrode? Counter electrode should be around like 10 times more than in area than your working electrode, and more than that also. So if you are, let's say, choosing your working electrode in area 0.12 centimeter square, then counter electrode area is around 10 times of 0.12 centimeter square. Okay, means 1.2 centimeter square around. So in this way you can choose your counter electrode. Then reference electrode. Reference is the obviously is a very important role, because whatever potentials you are applying with respect to a reference electrode. So normally what standard electrodes are used as reference electrode? First is your normal hydrogen electrode or standard hydrogen electrode, standard calomel electrode, AgAgCl, like metal insoluble electrodes could be used as reference electrodes, AgAgCl. many more. Normal hydrogen or standard hydrogen electrode, we know that a hydrogen electrode in which what you choose the standard conditions, means you choose activity should be 1, activity of your solution should be 1. So that is your normal hydrogen electrode, then standard calomel electrodes, and AgAgCl electrodes. So these are your references electrodes which you can choose to carry out your electrochemical measurement. So these are the fundamentals, very introductory part regarding the electrochemistry, the interfacial electrochemistry. In the upcoming videos, we will go in detail about the interfaces, about the double layer phenomena which are affecting how, what are the important factors which can like interfere in your electrochemical measurements, how you will see that, what are their functions, what are their importance. So these, all these things we will go in detail. Thank you so much.